Hello everyone, my name is Chetna Singh, Department of Computer Science and Information Technology at Sagar Institute of Research and Technology, Bhopal. Today we will discuss about the parallel projection, which just comes from Computer Graphics and Multimedia 6th semester. So let's start. What is parallel projection? Firstly, we discuss parallel projection. Parallel projection is a method used in a computer graphics to represent a three-dimensional object in two dimensions. Let's take an example. When we take a picture from mobile with the help of camera or mobile camera, we convert three-dimensional object in two dimensions. It is a type of orthographic projections employing parallel lines to project the vertices of the object onto the viewing plane. This technique is widely used in various applications like video games, land gaming, architectural visualization, and engineering designs. It is a generate a view of solid object by projecting points along parallel lines onto the display plane. Here you can see three-dimensional objects. This one, and this one. This is the three-dimensional object cube. And for if we want to project this three-dimensional object on a projecting plane, we simply use parallel projection. So with the help of parallel projection, we simply implement a rectangle in the view plane. Here you can see the view plane. It is a 2D plane to represent 3D object in the form of 2D, two dimensions. Here you can see this 3D object, square or cube, represent as a rectangle shape in the view plane. Here you can see another 3D object. From the top view, you can see the image or picture in the 2D plane as two continuous rectangles. From the front view, you can see images like a triangle with a rectangle. Same from the side view, you can see two rectangles with different width. Now, parallel projection used to display pictures in its true shape and size. When projectors are perpendicular to view plane, then it is called orthographic projections. The parallel projection is formed by extending parallel lines from each vertex on the object until they intersect the plane of the screen. The point of intersection is the projection of vertex. Parallel projections are used by architects and engineers for creating working drawing of the object. For complete representation required two or more views of an object using different planes. Here you can see the three-dimensional object. From the point A or top view, we can see object like this. From the side view, we can see the object like this in parallel projection. From the point C or side view, we can see the parallel projection like this. There are mainly five types of parallel projection: isometric, dimetric, trimetric, cavalier, and cabinet. Firstly, discuss isometric projection. In isometric projection, all projectors make equal angles, generally angle of 30 degree with the all axes. In dimetric, these projectors have equal angle with respect to two principal axes. For the trimetric parallel projection, directions of projection makes unequal angle with their principal axis. Cavalier projection, all lines perpendicular to the projection plane are projected with no change in length. In cabinet projection, all lines perpendicular to the projection plane are projected to one half of their length. These give a realistic appearance of the object. Here you can see the viewing volume in orthographic projections. Now you can see three-dimensional projection, and we convert it as a two-dimensional parallel projection of Earth. If we change the direction of projection, but we draw it on a 2D plane, then the object show like this. So in isometric projections, all three angles are equal. In diametric, two angles of two principal axes are equal, but in trimetric, all three angles are different. Now we discuss about axonometric projections or orthographic projections. Okay, here you can see object and all three angles are equal. Here you can see another object, but two principal angles are equal. And here you can see all three principal angles are different. So, when we talk about oblique projections, here you can see the true size of front is equal, but only differ is depth. Here you can see full depth or height. In cabinet oblique projections, height is just half from the full scale. But in general oblique projections, height is not full or half. When two equal axes and angle, and then corners my and mz are equal in length. When two equal axes and angles are equal but corners are also equal, then it's a Calabrier projection. But it is a military projection. Here two angles B and C is equal, but corners MX and MZ are also equal. This is a one-point perspective projections. Here we focused all our image from one point in a perspective projection. Then this is called one-point perspective projection. This is a two-point perspective projections. When there are two vanishing points in an image, then it is a two-point perspective projections. This is a three-point perspective projection because there are three vanishing point here in this image. So as you know, orthographic projections involves projecting the 3D object onto the 2D plane from different views, and this is create a true representation of object from various perspectives. But in isometric projection, object is round with all three axes equally. But also in cabinet projection, one set of parallel lines remain parallel and while the other set is drawn at half scale. It is an illusion of depth in a final projection. Thank you so much.